Hi, we are on the last lesson, believe it or not, of the longest unit of the year, Unit 4, which is mostly algebra. We have been solving simultaneous equations and most recently using our simultaneous equation knowledge to do some pretty cool stuff. And today, the last lesson of the unit proved just as exciting. This is unbelievable that this works. I haven't actually figured out how it works. I'm going to sit down tonight and try and figure this out because it is so darn cool. So what we're going to talk about today is we're going to talk about Pythagorean triples, Pythagorean theorem, and we're going to connect the Pythagorean theorem, this geometric truth about right triangles, and we're going to connect that with simultaneous equations, and again, how this works, I don't know, but it is really cool. So let's get on with it. We're going to learn how to find Pythagorean triples. Okay, so let's start off here. This is the last slide. Let's start with the first slide. So the first thing I want to do is I want us to recall the Pythagorean theorem. What is the Pythagorean theorem? What is it? It basically is a rule that says if you have a right triangle, and remember, we know that a right triangle is a triangle that has a 90-degree angle, right? A 90-degree angle. And it doesn't matter what the other two the angles are. These can be any measure. But if there's a 90-degree angle, we have these two pieces these two sides that touch the 90-degree angle, and these are called legs. And the opposite side has this weird name. The sides have this normal name called legs, but the opposite side that doesn't touch the right angle, the long side, it's also the long side, is called the hypotenuse, and that's just a really long, weird word. Anyway, so the rule says that if you have a 90-degree angle, if you square this side, the length of A, you say A squared, and you add it to the length of B squared, that's going to always equal C squared, the long side. So this is our Pythagorean theorem. And I'm not going to go into too much more detail on this. But the way it's usually stated is in a right triangle, the sum of the squares of the legs equals the sum of the square of the long side. So that's, I spelled that out maybe a little bit more verbosely in this blue language here. Okay. Now, what does this mean? So when you work the Pythagorean theorem, it turns out that usually one side is irrational, meaning it has a square root in it. So let's watch this. So if we have a side that's 1 and another leg is 2, then the Pythagorean theorem tells us that 1 squared plus 2 squared must equal this long side. We'll call that C. Must equal this one squared. So that 1 plus 4 equals C squared. So 5 equals C squared. So if C squared equals 5, then the number that you have to square to get 5 is the square root of 5. So C has to equal the square root of 5. And you can't simplify that. And, we've maybe talked about that before. Maybe we've talked about that in lesson 7. But anyway, it's not going to be an integer. It's not an integer. The only time, so let's move on. So usually you'll work the Pythagorean theorem, and again, one side is irrational. It's got this square root thing. And if you don't remember this whole square root thing, don't worry about it. The point of this lesson is not to confuse you. Let's move on. So the key to this lesson, or the point of this lesson, it says that sometimes the Pythagorean formula, the Pythagorean theorem, yields 3 integers. So let's see what happens here. And when we talk about, our leg is A, B, and then C. So let's see if we got A squared plus B squared equals C squared. Here we have 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared. So 25 equals C squared. So if c squared is 25, then c is equal to 5, right? Because if we take c, we square it, we get 25. So in this case, our Pythagorean theorem tells us that our sides are all integers. And that's really cool. When that happens, we have a Pythagorean triple. When this happens, this is meaning all sides of a right triangle measure, lengths are integers. Or more correctly, even, whole numbers, because they can't be negative. Really, they are whole numbers. But yeah, right, they're not fraction, they're not irrational numbers, they are whole numbers. And okay, so these are Pythagorean triples. Okay, so let's move on. Now, if you have a Pythagorean triple, so again, we have a Pythagorean triple like 3, 4, 5, you can actually double the size of each side, and you'll still have a Pythagorean triple. So 6, 8, and 10 is a Pythagorean triple also. And let's see why that's true. So we have this one Pythagorean triple. This is triangle 1. It had 3, 4, and 5. Here, if we have 6, 8, and 10, because we multiplied each side by 2, let's see. So we test it by saying 6 squared plus 8 squared equals 100 squared, 10 squared. So does 36 plus 64 equal 100? And the answer is yes, it does. So we've just shown that multiplying by 2 will give you a Pythagorean triple. Multiplying by 3, you'll get 9, 12, 225. Sorry, 15. I squared it in my head. So let's see if that works. That would be 81, which is 9 squared, plus 144. Does that equal 225? Does 9 squared plus 12 squared equal 15 squared? And the answer is yes, because 81 and 144, you add them together and you get 225. So you can see that, multiplying each side by a constant, and this is going to be on your homework, by the way. If you have a Pythagorean triple, just multiply by a constant, and you'll still get a Pythagorean triple. So here we got 30, 40, and 50. That's a Pythagorean triple. And you can verify that by verifying that 30 squared plus 40 squared equals 50 squared. And you can actually also find other triples by, you could even divide by 5. So 3/5, 4/5, and 5/5, because this would be times 1/5. This is also a right triangle. I don't know that this is a Pythagorean triple because it's a fraction, but it is certainly with legal sides of a triangle. Okay, because 3/5 squared, you can do your math on this one, because 3/5 squared plus 4/5 squared does in fact equal 5/5 squared. You can go and check that yourself. Okay, so that's kind of just a simple thing about Pythagorean triples. If you had a Pythagorean triple, and I'll tell you that there's one called 7, 24, and 25, you could find another one by multiplying by 2, and you could say that, well, I know that 14, 48, and 50 must be a Pythagorean triple if 7, 24, and 25 is a Pythagorean triple. All right, I just wanted to hit this, and I know I went over that really fast, but I want to get to the heart of the lesson, which is this next slide. Now, this is what is totally cool, and maybe why I raced so fast to get here, because this is just awesome. 4,000 years ago, the Babylonians used to use this method to find Pythagorean triples. Now, I don't know if in 8th grade they were doing this, but there were very smart Babylonians that knew that if you solved this simultaneous equation, you could find Pythagorean triples. But the way that you set it up, you had to come up with 2 integers, s and t. So let's pretend they're really whole numbers, or counting numbers. I'm going to call them counting numbers. Counting numbers, S and T. So let's come up with some counting numbers, S and T. Let's come up with some really simple ones. How about 1 and 2? We'll use 1 and 2, and then we're going to come up with again. Watch how this works. This is cool. So we're going to say, well, our S and T are going to plug in to here and here. So we have to solve for X and Y, and I'm going to just switch colors so we'll see that the math part will be in pink. So we'll say X plus Y has to equal, and we'll say specifically that S equals 1 and T equals 2. So T over S is 2 over 1. So X plus Y equals T over S, and then X minus Y equals S over T equals 1/2. Now the claim is, if we solve this set of equations and then we put the answers into fraction form like this, that we will have a Pythagorean triple with B, A, and sorry, this isn't exactly. I typed this in wrong. It's but it's close. Bear with me. This isn't bogus. And we'll make it a different color again. We'll make it orange. So it's C over B and A over B, right? And so this would be our X, and this is our Y. So if we solve for X and Y and we put them in fraction form, then our Pythagorean triple will be A, B, and this should be the same, and then C. So let's watch how this works. It's totally cool. It might be a little mysterious and not make full sense to you right now, but let's just work through this. And this is the coolest thing ever. Okay, so now we're going to add down, because this form will always work. Elimination will always be the key, the first step that you're going to want to do when you're using this method that the Babylonians used 4,000 years ago. Because if we just add down, we eliminate our Y. So we get 2x equals 5/2. Right? Because let's do our math. 2 over 1 plus 1/2 equals 4 over 2 plus 1/2, because I have to have a common denominator. So 2 over 1 is equal to 4 over 2. So that equals 5 over 2. All right, so 2x equals 5/2. So if I divide both sides by 2, or let's see, I'll multiply it by half. That's an easier way to see the answer. So I get x equals 5/4. So there's my x. Now let's solve for y. So x plus y equals 2 over 1. So 5/4, this should be old hat to you now, plus y equals 2 over 1. Let's just multiply everything through by 4 just to make it easy. So we're going to multiply this whole thing by 4 to get rid of our fractions. So we get 5 plus 4y equals 8. Subtract 5 from both sides, and I get 4y equals 3. So y equals 3 over 4. So let me put my answers together. So my answer is 5, 4, 3, over 4. And now watch this. I'm going to copy this over. Remember, here's the form. C over B equals A, or A over B. So my denominators are the same, so that's my B. So B equals 4. My C is my X value. So my C is 5, and then my A value is 3. So voila, look at that. How cool. I have my Pythagorean triple of 3, 4, 5. So remember, I showed you this on the last slide, but we can always check it. 3 squared plus 4 squared equals 5 squared, because 9 plus 16 equals 25. And that deserves a giant happy cat. A giant happy cat. we're going to do this again. We're going to do this again because it's really sometimes kind of hard to see. Or we're just going to practice. Okay. So we just used, last time we used t equals 1 and t equals 2. So we need to use some different fractions. Let's try some other easy ones. T equals 1. Sorry, and s equals 2. So now let's try t equals 1 and s equals 2. Let me make sure. Let's just go back really quick and make sure that's what I did. I had s is 1 and t is 2. So now I'll do we'll do s is 1 and t is 3. Okay, let's do this in a different color. So we have to solve the simultaneous equations x plus y equals t over s and x minus y is equal to s over t. Remember, so elimination is always going to be our first step when we're using this formula. So we get 2x equals 10 thirds. 3 is 9 thirds because 3 is 9 thirds, right? So 9 thirds and 1/3 is 10 thirds. Now we're going to divide both sides by 2, and so we get x equals 10 over 6. Okay, so there's our x, 10 over 6. Let's see. So y, x plus y equals 3 over 1. Our x is 10/6 plus y equals, and I'll convert this into 6 to make it easy, 18/6. That's an easy way to solve it. Now I see, well, 10/6 plus how many 6 equals 18/6? Well, that's got to be 8/6. So our y has got to be 8/6 because 10/6 plus 8/6 equals 18/6. So y equals 8/6. So here we go again. We have our b equals 6, our a equals 8, and our c is 10. And we know that 6, 8, 10 is also a right triangle because 6 squared plus 8 squared equals 10 squared. So 36 plus 64, right? 6 and 6 is 10, plus 60 is 70, equals 100. And that it deserves a happy cat. Okay, good. So let's try one more, and this will be it. So let's try s equals, let's try s equals 2. And t equals 3. Again, not too hard. We're sticking with low numbers, but you could make giant numbers and find some really big values. So let's go x plus y equals 3/2, and x minus y equals 2/3. Well, we got to find a common denominator here. So this is 4 over 6, and this is 9 over 6. Right? 3/2. The common denominator is 6. So times 3 times 3. And here I'm going to multiply by 2 times 2. Okay, so if I add down, I get on my left side, I get 2x. My y's cancel. And that equals 13/6. So now if I divide both sides by 2, I get x equals 13 over 12. Okay, so let's do our x plus y equals 3/2. So let's say 13/12 plus y equals 3/2. And I'm going to do the same thing I did last time. I'm just going to convert this thing here into 12ths. And then it'll make the math really easy. 13/12 plus y equals, I got to multiply by 6, equals 18/12. Well, if 13/12 plus how many twelfths is 18/12? Well, that's got to be 5/12. So y has to be 5/12. And to answer our question about our pair, or our Pythagorean triple, there's our B, here's our A, and here's our C. So we have here's our right triangle, and we have 5, 12, and 13. So let's make sure that 5, 12, 13, let's make sure that works. 5 squared plus 12 squared equals 13 squared. Does 25 plus 144 equal 169? Well, 25 and 124 is, yeah, 169 equals 169. And that, my friends, deserves a happy cat. And a spinning, purring happy cat is what we like to see in Mr. Lipscomb's math class. Uh-oh, this is not the right title. Let's fix the title here before someone says, Mr. Lipscomb, what are you doing teaching the last lesson here? Whoops, I'm not sure what's going on. It's not showing up. The title is not showing up. But anyway, okay. I will get back to you guys in 8 and 5. We will hit 8 and 5 with the next lesson. That'll be 8 and 5, lesson 1. We have finished. Give yourselves a big hand. We have finished 8 and 4. That was 31 lessons of pure joy, pure algebraic bliss, simultaneous equations, solving, converting verbal models to graphs, to charts, to algebraic equations, and then even learning about how to convert Fahrenheit, or deriving formulas for Fahrenheit conversions to Celsius. We learned about how to even create Pythagorean triples. This is the heart of algebra in 8th grade. You guys have got a solid foundation, and let's just keep building and building through the last 2 units, which are actually a lot shorter. The last 2 units are 11 lessons and 14 lessons, so just 25 lessons. Together, those unit 5 and 6 are shorter than 8 and 4. So we'll leave it there, and we'll talk to you soon. Good work.